Hello students, welcome to my channel Reaction House. Today we discuss about different conformational analysis of acyclic system and start this topic by taking some examples. So first one is ethane. You know, the ethane molecule contains only one carbon-carbon single bonds and about which free rotation is possible. So rotation about carbon-carbon single bond in ethane molecule can give various conformers, and in these structures when two hydrogen atom are completely overlap with each other, then it called eclipse structure. And when in ethane molecule two hydrogen atoms are fixed at 60-degree dihedral angle, then it is known as staggered conformation or anti-conformations. And various other structures in between eclipse and staggered conformers are called skew conformation. And eclipse conformation of ethane molecule can be converted into staggered by rotation of 60-degree about carbon-carbon single bond. So if we start from eclipse structure, first one is eclipse structure, and if we rotate the front carbon or back carbon about 60-degree clockwise, then it transferred into staggered structure where the dihedral angle of two hydrogen atom is 60-degree. Similarly, when this staggered structure we rotate again about 60-degree clockwise, then it again transferred into eclipse structure. So we can say the eclipse form of a ethane can be converted into staggered by rotation of 60-degree about carbon-carbon single bond. Thus, total rotation of 120-degree from here to here, total rotation of 120-degree about carbon-carbon single bond will give same conformations in ethane. You see, these structures and these structures are same. So the total rotation of 120-degree, and you can find if we rotate the front carbon or back carbon about 120-degree clockwise, then you transfer this structure from this structure. So the total rotation of 120-degree about carbon-carbon single bond will give same conformations in ethane. So in energy profile diagram, the energy of eclipse form in ethane molecule is greater than that of staggered form due to steric hindrance. In case of eclipse form, as their two hydrogen are partially overlap with each other, then there occurs some steric hindrance. Therefore, they are unstable compared to staggered structure, because here two hydrogen atom are present anti-position. Therefore, the repulsion of two hydrogen atom are lower than eclipse structure. Therefore, the eclipse structure less stable than staggered structures. So energy of the eclipse form is greater than that of staggered form due to steric hindrance, and thus staggered form is more stable than eclipse structure. We can explain this fact by taking this graph, and this is the energy profile diagram of ethane molecule, and we can find that various rotation of ethane molecule give different energy state. Among them, the staggered structures have lowest structure than eclipse structure. So we can say that eclipse structures are less stable than staggered structures. So this is the potential energy change by rotation about carbon-carbon single bond. Next one is propane. In propane, the graph is similar to that of ethane, but in propane, the rotation about carbon-carbon single bond again gives staggered and eclipse conformation, but due to one methyl group extra, this one methyl group extra, uh, the torsional strain is increased, because in case of ethane there present one hydrogen atom and repulsion occur between two hydrogen atom, but in case of propane the repulsion occur between hydrogen and methyl group. Therefore their torsional strain is increased, and again a rotation of 60 degree about carbon carbon single bond convert eclipse form to staggered form, or vice versa. Therefore, we can say the energy profile diagram of propane molecules is very similar with the ethane molecules. And next one is butane. The butane molecules is very interesting because in case of N-butane, the rotation about carbon-carbon single bond, the C2 carbon and C3 carbon single bond gives various conformations which are shown in this figure. And start this rotation from eclipse structure where two methyl groups are overlap with each other. Therefore it is known as fully eclipsed because the repulsion occur between two methyl groups, and it is most unstable structures among all the conformers because they are more steric hindrance occur. So when this complete eclipse structures, and you can find the energy of these eclipse structures is higher than that of all, compared to that of all molecules. And when this eclipse structures is rotate about 60 degree clockwise, then it transfer into gauche conformers. And you know, when the torsional dihedral angle between two methyl group is 60 degree, then it transfer into gauche conformers. So this is gauche conformers, and here repulsion is quite lower than eclipse structure. So the energy of this gauche conformers is lower than that of eclipse conformers. So when we again rotate this molecule clockwise about 60 degree, then it transferred into eclipse structures again. But these eclipse structures are different from previous one, because in case of previous one their two methyl groups are eclipsed with each other, so there occur more repulsion. But in case of this eclipse structures, there one hydrogen atom eclipsed with one methyl groups. Therefore the repulsion of these eclipse structures are quite lower than uh, fully eclipsed structures. Therefore it is known as partial eclipse structures, and the energy between these two molecules, you can find there are slightly difference in energies. Again, if we rotate the butane molecule about 60 degree from this partial eclipse structures, then you can find it transfer into anti-conformers. And in case of anti-conformers or staggered structures, their two methyl group are completely trans with each other. Therefore these molecules or these conformers are stable compared to all of these conformers, because here occur less steric repulsion among them. So this is the most stable conformers among N-butane. And again, if we rotate this molecule 60 degree, then it transfer into partial eclipse structures, and these partial eclipse structures, the energy of these partial eclipse structures are quite similar with the previous one, because they have same conformers but difference in their angle. First one have plus 120 degree angle, and second one has minus 120 degree angle, and it is denoted by P or M conformers in helical chirality. And if this molecule again rotate a 60 degree, then it transfer into gauche conformers which have similar energy to the previous one. So this is the energy profile diagram of butane molecules, and these above 6 conformers are obtained on each successive rotation of the group bonded to rare carbon by angle of 60 degree. Among these, the anti-conformers is the most stable. This is the anti-conformers, and which is more stable conformers, because the bulky methyl groups are at maximum distance, and the fully eclipsed structure, this one or this one, the fully eclipsed structures is the less stable, because the bulky methyl group are close and providing maximum repulsion and has higher potential energy. And the stability order of these conformers is shown in this figure with compared to the energy profile diagram. So next one is very important, that is butane gauche interactions. And the conformers of two gauche conformers, that is first one is there and second one is there, the two gauche conformers with torsional angle plus 60 degree and minus 60 degree. In case of this, the torsional angle is plus 60 degree, and this have torsional angle of minus 60 degree. So these two conformers with torsional angle of plus 60 degree and minus 60 degree respectively are non-superimposable mirror image of each other, and this is two isomers of gauche conformers, and these conformers are superimposable mirror image of each other and form an enantiomeric pair. They have a C2 axis passing through the midpoint and of the two C2 and C3 bonds, and bisecting the dihedral angle between the two methyls, and belong to C2 point group. So these two conformers have C2 point group, and they are called gauche or skew conformers, and their absolute conformation may be conveniently designated as P or M in terms of helical chirality. In case of this, they known as P chirality. In case of this is known as M chirality, because the angle between CH3 and CH3 is plus 60 degree. So this is known as P chirality, P for positive chirality, and the angle between CH3 and CH3 in case of this, that is minus 60 degrees. So it is known as M conformers. So we can say these two conformers as P or M in terms of helical chirality, and these two conformers are EQ energetic and have a potential energy of 3.3 kilojoule per mole above that of anti-conformers. And anti-conformers is more stable structures in N-butane, and due to this two gauche conformers have slightly repulsive force occur between them, and they have potential energy of 3.3 kilojoule per mole above that of purely anti structures. So this energy occurs due to the steric repulsion between two methyl groups. Therefore, this interactions known as butane gauche interaction. This is very important, butane gauche interactions. Next one is calculation of percentage of anti and gauche forms of N-butane. So you can find from this energy profile diagram that anti form is more stable than gauche form, and we discuss about this in the former slides. So this anti conformers is more stable conformers than gauche conformers due to steric repulsion. So in case of N-butane, the in case of N-butane, the different structures have different energy, and the population of the various conformers are related to their energy difference by a simple equation, that is del G is equal to minus RT ln K, where del G0 is the conformational free energy, which is equal to the excess of standard free energy of one conformers over that of minimum energy conformers. And R is the universal gas constant, T is temperature in Kelvin, and K denoted by equilibrium constant. So this is the equation where we can find various free energy change of different conformers. And in case of N-butane, there arise a equilibrium, that is anti-gauche equilibrium, and this anti-gauche equilibrium has free enthalpy value, that is del H value equal to minus 0.8 kilocalorie per mole or 3.36 kilojoule per mole, which I discussed in previous. So this energy gap between two conformers is minus 0. This energy gap between two conformers is minus 0.8 kilocalorie per mole, and this energy gap occurs due to the butane-gauche interactions. So in case of these conformers, there are two enantiomorphic gauche conformers. First one is this and second one is this. So there have two enantiomorphic gauche conformers. So the statistical factor of these conformers is 2, and which favors the gauche forms, and these two enantiomorphic gauche conformers leading to an entropical advantage, and we can denoted this entropy by del S0 is equal to minus R ln 2. Here 2 implies the statistical factor, and which is arise due to two conformers, two gauche conformers. Therefore we can find the del G0 value from this equation, and you know del G0 equal to del H0 minus T del S0, and if we put the value of del S0 into this equation, then you can find del H0 is equal to minus 0.88 and del S0 is equal to minus R ln 2, and after the calculation you can find the value of del G0, which is equal to minus 1.64 kilojoule per mole. So the value of del Z0 is minus 1.64 kilojoule per mole. If we put this del Z0 value into the first equation, that is equation number 1, then you get the K value equal to 2, and this K implies the equilibrium constant. Therefore we can say that K equal to NT by gauche equal to 2, and this value indicate the different distribution in N-butane of various conformation, and the antiforms in N-butanes is about 64%, which is more stable because they have low steric hindrance, and the gauche conformers in N-butane is about 34%, and this percentage decreases due to butane gauche interactions. Next one is different conformers of ethylene glycol, and you know in case of ethylene glycol there three conformers are possible, that is partially eclipse, where one hydrogen atom overlap with OH molecule or hydroxy molecule, and second one is fully eclipsed structures, where two hydroxy groups are completely two OH groups are completely overlapped with each other, therefore it is known as fully eclipsed structures. And third one is gauche structure, where the torsional angle between two OH group is about 60 degree, and among these two conformers, the gauche conformers is more stable. So we can find that ethylene glycol exists almost exclusively in gauche forms, where this is a stable intramolecular hydrogen bond, and you find there is a stable intramolecular hydrogen bond between these two OH group. Therefore, this gauche conformers is more stable compared to others two conformers. So, for this reason, ethylene glycol has considerable dipole moment, and this gauche conformers is recognizable by the IR spectroscopy. And if we transport these OH molecules by any electronegative atoms such as OH, NH2, fluorine, chlorine, bromine, or NH2, etc., then the stability of these conformers are same as ethylene glycol. So there occur a strong attraction force between electronegative atoms and OH group. Therefore, gauche conformers are more stable for this type of molecules. Second one is stability of butane 2,3-diol, where they exist in two conformers. First one is mesoconformers, where the two OH groups are eclipsed with each other. Therefore, there exists a mirror image plane, and this is optically inactive. So in case of butane 2,3-diol, the meso isomers, there also present a hydrogen bond between two OH group. This is the meso structures, and they're all, if we transfer these meso structures into Newman projection, then you can find there also a hydrogen bond between two OH molecules, but here two methyl group are present gauche conformers. Therefore, there exists a steric repulsion between two methyl groups. Therefore, these meso conformers are unstable. Second one is DL isomers of 2,3-diol. In case of DL isomer, if we find a Newman projection of this DL isomer, then this DL isomer also have hydrogen bond stabilization, but here the methyl group present at anti-position. Therefore, the repulsion of these two methyl group are lower than compared to mesoform. So we can say the stability of butane 2,3-diol, here the optically active forms, that is D form or L form, is more stable than compared to mesoform. So this is the stability of butane 2,3-diol. So I think for today this is enough, and thank you.